irreducible and reducible polynomials. Let R be an integral domain. A polynomial f of x which is in R of x is said to be an irreducible polynomial over R if it can't be expressed as product of two polynomials of positive degree. See, for example, I will consider the polynomial f of x equal to 2x square plus 2. This is a polynomial in z of x. Now, I can write this polynomial as 2 into x square plus 1. Though we can write this polynomial as 2 into x square plus 1, product of two polynomials, but this is not of positive degree. Degree of this polynomial is 0. Therefore, this polynomial is irreducible over z of x. Or else, one more way of checking the irreducibility is for a polynomial of degree 2 or 3, you have to check is that polynomial having a root or 0 in that field f. If that has a 0, then the polynomial is reducible or the polynomial is irreducible. See, for example, take this polynomial f of x as 2x square plus 4. Now 2x square plus 4 equate this polynomial to 0. X comes out to be plus or minus square root of minus 2. Square root of minus 2 is not a real number. So this polynomial is in R of x, but the root is not in the field R. Therefore, f of x has no 0 in R. Therefore, this polynomial is irreducible over R. But this is reducible over C because in the complex numbers, this polynomial has roots. Similarly, you can check this polynomial is not having any root in z of x. Hence, this polynomial is irreducible over z. Consider this polynomial f of x as x square minus 2. This belongs to q of x, the polynomial ring. Now you equate this to 0, this polynomial to 0, and check whether this polynomial is having a root in q or having a 0 in q. So x square comes out to be 2x equal to plus or minus root 2. This is not a rational number. Therefore, this polynomial is not having any 0 in q. Hence, it is irreducible over q of x. But this polynomial is reducible over R because square root of 2 is a real number. Hence, this polynomial is reducible over R of x, whereas it is not reducible over Q of x. Consider one more polynomial f of x is x square plus 1. If you consider the field Z3, under Z3, this polynomial is irreducible. That is because it is not having any 0. But the same polynomial is reducible over Z5. 2 is a 0 of this polynomial under modulo 5.